Number 37. Some students measure the masses and volume of different sized samples of a type of food. Which graph shows their results? Measures the masses and volume of different sized sample of a type of food. Which graph shows their result? Okay. On y-axis, we have mass. On x-axis, we have volume. So mass over volume. Okay. So we know that density is actually mass over volume. So it means if we compare it with the gradient, like normally the formula for gradient is y2 minus y1 over x2 minus x1. And we have designed a hint for ourselves that when there is a when gradient is constant, the graph would be quite similar to it would be a such type of graph. A straight line graph means the gradient is constant. So now look at the statement. It states that size of a type of food, different sizes, but the type is same. So if their size increases, their mass also increases. So if a small wooden piece can't be zero in size, so I think this one let's discuss all of them one by one. It says the material will have different density, like the mass over volume is density. So if we calculate the gradient of this graph, that is density, and it tells us that the density will vary. So that's totally wrong, because for a single material the density is same. This graph shows that if you the mass, if you increase the size of a wooden piece, the mass decreases, and at a certain value of mass, the at a certain value of volume, the mass would be zero. Look at this argument. It says when your volume is zero, the mass is maximum, and when your volume would be maximum, mass would be zero. That's totally a blunder. And look at the option B. It says when your mass is zero, your volume is zero. And when your mass increases, when your volume increases, when your mass increases, your volume also increases. When your mass increases, your volume increases. And kind of little acceptable type of thing. And 0 over 0 is not acceptable. Like it looks little unusual type of thing. It means mass 0 and volume 0, and density is 0 over 0, which is in mathematics it is not allowed. So I think we should cross this one. Okay, this option. Okay, y-axis is missing. I can draw y-axis. Suppose y-axis is somewhere here. Okay. For this, Like you can see the graph is not going to start from zero. Like it starts from a particular mass and particular volume and then increases. But this straight graph means the ratio remains same. So that's why we are going to consider this option, which is an acceptable option. Number 38, an object has a mass of 15 kg. So mass is known. An object has a mass of 15 kg. It means we know the mass of an object, and it is on this on the earth is taken to moon. So from earth we are going to take it to moon. The gravitational field strength is 10. We know it that the gravitational field strength on earth surface is 10, and on moon it is 1.6. So we can calculate the weight on earth is mg and mass is 15 and g is 10 on the earth surface, so it is 150. So weight on earth is 150 and weight on moon is 15 times the gravitational field strength would be 1.6. So if we multiply them, it would become 24. Okay, now let's move to the question. What are the mass and weight of the object on moon? So mass of the object on moon is same as on earth. So this is 15 and 15. And weight of the object on the moon is, and weight of the object on moon is 24. We have just calculated. So 24 and 24 are the options. Okay. This is our correct option. A student is trying to find the density of a stone, but he has mixed up the instruction cards. Okay, like card 1 is this one, card 2 is this one, card 3. Find the mass of the stone using mass balance. Read the new level. Like first you will find out the mass of this stone, then you will put this stone into the liquid, and then you will find out the amount of increase in volume, how much is the volume is increased. Then you will divide mass with the volume to find out the density. These are the original cards. Okay. Now he mixed the cards. He mixed the card, and what is his new sequence? Put some liquid into measuring cylinder and read the level of the liquid. Okay. Suppose the volume is 20. Then he put put uh, put it like the stone is immersed into the liquid. Now there would be a new volume. Subtract the original volume from the volume of the liquid plus stone. Okay. Okay. What order should the card be in? Now we need to find out the order in which yes. So first is to find out first of all, He should measure the mass of the stone, that's fine. Then he should measure the volume, that is this, that should be the second thing. Now the third one would be the put the stone into the liquid. Now this would be the fourth one, read the new volume of the liquid. Okay, so that's incorrect. Fourth one would be this one. Flick the cylinder to get rid of any air bubbles. Okay, then fifth one must be like this. Then sixth one would be like this, because you subtract the volume from the. Now seventh would be like this. Now our order would be, it's a rearrangement. So 1, then we will have 5, then we will have 3, then we will have 6, then we will have 2, then we will have 7, then 4. So this is the sequence. Okay, now let's match. 1, 1, 5, 3, 1, 5, 3, 6, 2, 7, 4. Okay, this is our correct option. Okay, now let's move to question and see why. First of all, we will measure the mass of the object, mass of the stone or whatever. Then we will measure the volume of the liquid. Now we will put this mass into the liquid, which is situation like this, and then we will flick it so that if there are some air bubbles, those can go outside. Then we will measure the new volume. After measuring the new volume, we will subtract it from the previous volume, which is here. This is the volume without the stone. This is the volume with stone. Now we will subtract them. After getting this is the sixth stage. Now we have volume of the stone and we have the mass of the stone here. Now we will divide them and then we can get the density. Okay. Next is which relationship defines gravitational field strength? We know that gravitational field strength is from the formula of weight is mass into gravitational field strength. And gravitational field strength is weight over mass. So our correct option is weight over mass. So weight over mass is this one. So these are incorrect options. Number 41. A measuring cylinder contains water stands on a scale pen. This is 30 centimeter and its mass is this one. Okay, a solid ball is lowered into the water. Now you put some solid ball in it. Now you can see the volume is increased from 30 to 40. So we can find that new volume is 40 minus 30. Previously it was 30. So we can find out the difference, which is 10. Similarly, you can see the previous mass is 100 grams and new mass is 180 grams. So you can find out the difference of masses as well. So mass is 80 grams. Now we can easily find out the density. Density is mass over volume. Mass is 80, volume is 10. 80 divided by 10 is 8. 80 divided by 10 is 8. Or you can simply, density is mass over volume, and it is 8. And our correct option is this one. Now number 42. 4 blocks, each made from a different material, like, are placed on a scale balance as shown in figure. In which diagram does the block have the greatest density? Like all of them 100 grams, and like you can see the small mass, like the mass is same 100. Oh, okay, its volume is small and mass is also small. It means, and similarly mass is little large and volume is little large. It looks, they are like, these are proportional kind of thing. So masses are same but volumes are different. Similarly, if you look at this part, volume is 200 centimeter cube and 250 centimeter cube. Okay, one side is, okay, mass and 100 centimeter cube. Again, here is 300 centimeter cube. Here is 300 grams. It is approximately 1. If you just measure like mass over volume, it would be 1. Just find out, it would be 2. Mass over volume is 2. It is 250 divided by 2. It would be 1.25, I think so. And what about this? Mass is 400 and volume is 350, and it is 0.8, maybe 87 or 86. Which has the greatest density? You can see the greatest density is of A. A has the greatest density. Number 43. On Earth, gravitational field strength now it is, again, it's a kind of 43 is a kind of repeated question. I'm not going to solve this. 44. 10 identical steel balls, each of mass 27, are immersed into the liquid of 20. The reading of the volume. So now there is a difference of volume. It means 50 minus 20 is 30 centimeter cube is the new volume, and mass is given